I'm glad to see y'all are still here and not already pre-gaming the party. Thanks, Anton, for practicing my name very hard. That Wichrowska sound, I know it doesn't exist in Swedish, so I think he did a very good job. My name is Maja Wichrowska, and today I'm going to be talking about code mods in the era of AI. So let's get started. If my clicker, there we go. Hey! A little about me. This is me. This is my dog, Rooney. He's going to feature very prominently in this talk, so I hope you are dog people. I've worked at Airbnb, Airtable, Notion, and I actually started at OpenAI last week. And throughout my career at all of these companies, I've always been in web infrastructure. So that means everything from React migrations, design systems, build infrastructure, so on. And so for this talk, I want to start by having you imagine a particular situation that I've ended up in over and over and over again in my career in web infra. It starts with a core framework library your application depends on releases a new major breaking version. Or maybe it's simply not scaling to the needs of your growing startup, or sometimes they remove some critical feature that's like really important to your app. Either way, the end result's the same. If you ever want to upgrade, you have to rewrite everything in your code base. And you're a web infra team in a product-focused company, so obviously there's no extra headcount, and there's no way the company's ever going to stop feature development. So you're basically trying to rebuild the whole plane while the rest of the company is still flying it. So what do? I'm going to list some options for us in an order of what I think is most likely to least likely. Number one, highest probability outcome. We do nothing. Some of you may have gone to Sophie's talk yesterday. This isn't necessarily a bad thing. The migration's not always necessary, and maybe more importantly, it's not always necessary right now. We may be able to stay on this legacy version for quite a while, and maybe nothing breaks, who knows? Our second option, this is kind of the web infra approach, is you write an ESLint rule. You disable that rule for the thousands of files that currently violate it, and everything new has to be in the new syntax or whatever you're trying to get going, and you just hope and pray that eventually all the old stuff goes away. Very effective, right? You totally don't have like 6 of these migrations in progress in your code bases right now. No, right? Okay, our third option, we're going to write an RFC. We're going to get leadership buy-in. We're going to staff a tactical Tiger team, and in 6 months, we're going to knock out this migration. How many of you have successfully done this before at your companies? These guys are the most important people in their companies. They have a lot of influence. I feel like your company should pay you more. Ask for a raise. Realistically, I'm not important enough to make this happen. So I feel like mostly this is only true for the most important security fixes and upgrades, and React usually doesn't cut it. So now, it's 2025, maybe we can ask AI. Or maybe another option, and one that I think is underappreciated, we can write a code modification script, or a code mod, to do the migration for us. What I'm hoping to convince you of today is that the answer is somewhere in between these two things. There are things the AI is good at, and there's ways where it fails catastrophically. And code mods are kind of hard to write, but they are safe, deterministic, and quite fast. And throughout this talk, I also want to keep your minds open to the changing landscape. Not every implementation of AI and tools is going to be good. There's a lot of bad ones out there. But we're going to talk about just how fast the landscape has changed already, and hopefully convince you to keep reevaluating the tools and fitting them into your workflows. So let's talk over what we're going to cover today. First, we're going to revisit the last few years of AI, especially in relation to coding tools. This isn't going to be comprehensive. I'm sure y'all are using like niche, weird models in everything that you do, but this is going to be an overview of my experience of the AI coding tools. Then we're going to think deeply about code. Again, in the world of AI, there's a narrative that maybe we don't have to like understand what's going on that well, but I think especially if we're trying to change thousands of files at once, it's really important to think about our fundamental mental models of code. And then finally, we're gonna go through 2 case studies, 2 migrations, just 2 years apart, that we tackled at Notion. And we're gonna see how Codemods and AI both fit into these situations. So let's recap the very recent history of AI coding tools. I'm also gonna include a few Notion milestones in here, just so you can get a sense of the environment that I was working in while we were tackling these migrations. I know we could start decades back, but we're not going to go back to the 1970s. Instead, we're going to start just 4 years ago, in June 2021, when GitHub and OpenAI first launched Copilot, which was built directly into VS Code. I don't think anyone was really billing this as transformative at the time. We were having a lot of conversations about like, does it work? Does it hallucinate? Is it correct? But mostly I feel like we treat it as a fancy autocomplete. And after this, I know there were some libraries and some new models being released, but I think the landscape didn't really start to accelerate until the fall. And Notion was actually quite early. We got a preview of GPT 3.5 a couple months before it was released to the public, and immediately jumped on integrating the AI into the product. So to give you a sense, basically from my first day at Notion, the leadership was thinking about AI. And then the next month, we got kind of another iteration of a VS Code extension, which was Codium, the company that eventually brought us Windsurf, building AI tools directly into VS Code. But November 2022 is when things really got crazy. This is when ChatGPT launched, and it introduced LLMs not just to developers, but to kind of the broader consciousness of everyone in the world. And things really started to accelerate. In just 2 months, ChatGPT hit 1 million users. And then in March of that year, we got Bard as an answer to ChatGPT, pre-Gemini. We got GPT-4. We got Claude 1.0 from Anthropic. And March was also when the first version of Cursor was released. So a lot going on in this 1 month. And that was the landscape when I joined Notion. We had relatively intelligent autocomplete in our IDEs, and we could talk to the LLMs about our code. But it wasn't really something that we could leverage for these large-scale migrations. And then, there continued to be developments, but I think that the next paradigm shift really only occurred when we started talking about agents. At the end of last year, and I just want to emphasize, this is like not even 12 months ago when this stuff started really unraveling. At the end of last year, Codium rebranded as Windsurf, and I'm not going to lie, I've never used Windsurf. But I think what's important is they started talking about themselves as the first truly agentic IDE, capable of adding files, making edits, grep, listing files in a directory, even executing code. And in a fast follow, January of this year, Gemini had the same marketing. They released a new model with agentic capabilities, and even with a new experimental AI coding agent. But for me, my first oh shit, this is gonna take my job moment was in February, when Anthropic released Claude Code. This was a command line tool that really allowed us to delegate tasks directly from the terminal. It was clear that this was something very powerful and potentially very useful. So why talk about this history of tools at all? Well, I think in just 5 years, we've experienced a massive evolution in how we write code. We've gone from copy and pasting from Stack Overflow, just kidding, totally writing code that we made up on our own, to using AI as a fancy autocomplete in 2021, to interrogating the AIs about our code, and sometimes even using them to produce code snippets that we pasted back into our code bases. And finally, just this year, to producing greenfield applications and new features with natural language prompts. At each of these inflection points, both the capabilities of AI evolve and also the limitations. And these are the differences that we have to think about to best leverage the tools in our work. Who knows what the future will hold? But one truth is evident to me, and that's we really need to understand how we think about code to know how AI is different and where it can replace, augment us, and where it can't. So, let's think deeply about code. For me, one anecdote that has exemplified the differences between me and the machine is a particular conversation I had with ChatGPT about my dog. I told you we'd get back to him. Here's my dog, Rooney. You may notice he's a very good boy. You may also notice he does not have a tail. Earlier this year, I asked ChatGPT to create a cute black and white illustration of Rooney. And no matter how hard I tried, I just could not get it to understand the concept of a freaking tail, let alone produce an image without one. And I do have to say that ChatGPT's image gen was still quite impressive and miles ahead of certain competing models at the time. I mean, I guess technically that dog doesn't have a tail, but look at this muscle definition. What I'm trying to say with these dog pictures is that obviously the AI thinks differently than we do. It does not have a mental model of a dog as an animal with a head, 4 legs, and a tail. And the result is that it really isn't able to identify when things don't match reality. Is the same thing true with code? Does it lack a human engineer's mental model of code? And that, of course, begs the question, do we know what our mental model of code is? Let's take a look at an example relevant to one of the migrations I'm going to talk about. A React class component. What are we actually thinking about when we look at this component and try to modify it? Well, we see a class declaration that extends another class called component. That class declaration can have any number of class methods, and they can be declared in any order, but for a component, we know at least one of them is a render method. Within these class methods, we have all sorts of different statements, function calls, variable declarations, and return statements, and so on, and they execute in a particular order. And within each of these statements, we may reference this expression, which is critical to think about because that's what makes a class method different from a standalone method outside of the class. And what we actually end up with when we build up a mental model of this piece of code in our head is a tree. That funny kind of upside-down tree that we're most familiar with in programming, but a tree nonetheless. In JavaScript, this is called an abstract syntax tree, or an AST. And ultimately, ASTs are the paradigm that allow us to build lint rules, Babel plugins, and of course, Codemods. But even if you don't do any of that in your day job, you're still likely thinking about your code in this way, even if it's subconscious. And these mental models are important. They are what let us know that this is a dog with all its relevant features, things we can easily point out, like the head, the legs, and things we can't, like that still end up making this a dog even though it doesn't have a tail. And similarly, it lets us know that this piece of code with a class declaration that extends a component and has that single render method that returns JSX, mental models let us know that this is a class component. Who knows what the mental model of an AI is? Or if that's even a question that makes sense. And what's more, it's changing all the time. The fact that I don't understand how it thinks about this dog or this code is why I feel really nervous letting it loose on a large-scale migration where I can't necessarily review each line of code it changes. So how do we still make use of new AI tools given this paradox? Let's talk about 2 migration case studies that we tackled at Notion, almost 2 years apart, and how AI was useful, even though you can't trust it entirely. In 2023, when I first joined Notion, we determined that we needed to convert all of our remaining class components to be functional. And 2 years later, right before my departure from Notion, we determined that we needed to modularize our client code base. At first glance, these two projects maybe don't seem like they necessarily have that much to do with each other or with the proposition of AI or Codemods, but actually, there's quite a few things tying them together. First, both had been prioritized for the same reason, which is that performance was a P0. In the case of class components, their continued existence was actually preventing us from upgrading to React 18 and leveraging things like concurrent rendering and React compiler. And in the case of modularization, our code base was so entangled that even the smallest feature necessitated pulling in 2,000 files. And that was preventing us from getting our bundle size under 10 megs, which is ridiculous. That's too much code. Both were also of a scope that it was hard for an individual or for a small team to tackle in a reasonable amount of time. We had 700 class components remaining, which included some of our core functionality, and the most complex of them were over 4,000 lines long. And then, of course, client modularization was going to affect every file in our code base, and we had 10,000 files supporting our client app. And finally, both had significant portions that could be automated, but as well as complexities that made it a bit tricky. We had some simple class components that just had a render method, and we also had these behemoths with hundreds of class methods that simply couldn't be undone that quickly. In the case of modularization, as I mentioned, our simplest features were pulling in 2,000 files, so it's not really something that could be fully automated. We had to figure out some strategies and maybe do some manual work. So I developed a framework that I used to tackle these migrations, both in this job and before. Step 1, you try to do the migration manually for a small number of files. Detangle one little feature, convert a few class components, just to see what it's like. And then you outline the step-by-step algorithm for what you're doing. This can feel a bit tedious, but actually writing things down explicitly pays off. And then we can utilize whatever tools are available to scale it up. Maybe that's scripts, maybe that's some sort of GitHub integration, or maybe that's agents. And finally, we all know that last 10% of the migration is usually the hardest and probably requires some manual work. But the focus of using AI and Codemods is this 90%. If we can get through this 90% quickly and simplify the remaining 10% enough that it's less daunting, then we can really get these migrations fully completed and not just leave them hanging around in our code base for years. These 3 steps are what I'm primarily going to be talking about, although we'll briefly touch on the long tail as well. So let's talk about our class component conversion. First step, let's do it manually. We can start by converting the simple button class. There is a challenge where if the task you were assigned was convert this button class and not figure out how to systematically convert all class components, you probably wouldn't really think about it, you'd just do it. And AI makes this worse, because maybe you just ask ChatGPT, hey, convert this, and instead of thinking about what it's doing, you'd spot check it and you'd be like, that looks good. But I want to actually take the time to break down what it is that we're doing. When we look at the button class component and the intent to convert it, what do we actually pay attention to? Well, I'd probably look at the class declaration, where the component name's defined. I note that we have this props type up here and that it's also referenced in that superclass. There's, of course, this render method and the body of that method. And there's a reference to this.props, which we're not going to be able to take with us into the functional component world. And when we look at our converted component, we see the same component name, the same props type, the definition's untouched, but you see that we've moved the type into the first argument, almost exactly the same render method body, with the exception that we've updated this.props to just be props. So we have the first draft of our algorithm. First, we check class is a class component. Then we find the component name. Then we find the props type and the body of the render method. We replace any this.props with just props. And then we create a function with all of the information that we just pulled out. Easy. The problem is, life is never that simple. This was our worst offender. This is the collection view block. If you've ever used a Notion database, this has all of the code that powers the Notion database. It's 4,066 lines long, it has 41 class properties, and a whopping 122 class methods. So how do we tackle things like this? Well, I don't know. I guess one thing I noticed when I was manually converting more complex components is that there were a lot of class methods like this that didn't even have this expression, which means there's no reason why it had to be on the class. You could just extract it in the same file at the top level, and then you're one class method down. What if there's a class method with a reference to this.props? Well, you could just use that as an argument into your extracted method. What if it references another method on the class? It's the same thing. You first extract that method, and now there's no this expression. You can extract this one as well. So, when we look at our algorithm, we already have our strategy for converting a component where all it has is a render method. That's what we use in this case. And then if it's more complex, we extract a method and then repeat. Eventually, the component becomes simple enough that we can convert it via our conversion algorithm, and we're happy. How do we execute this at scale? Remember that it's 2023, so we're not exactly at the agentic workflow stage. We're still mostly in the prompt and response aspect of ChatGPT, so that seems kind of painful for actually converting all these components. And again, because the AI does hallucinate, you're going to have to review every line of code it generates. So maybe that's not something that we can trust. So let me introduce my favorite code modding tool, JS CodeShift. This is an open source library that was built by Meta a decade ago, but I think it's still highly relevant to automating code migrations today. There are other tools available, although not like that many, surprisingly. Like I've been playing around with TS Morph this week, but I still think this is a solid choice. It's fast, it runs on thousands of files in seconds, it has built-in TypeScript and JSX support, it's well typed, so you can pretty equally develop new transforms. So looking at a JS code transform, it's just a function. This one, for example, replaces all variables with the name foo with variables with the name bar. The important bits are here. This reads the source code, and it's every file that it encounters. You run it on folders, so it's just running in parallel on your entire code base. It converts that string into an abstract syntax tree, which it then does some gobbledygook to. That's a technical term. And then it transforms it back into a string and returns it from the transform. So how does this work for our algorithm? Step one, we check if there's a class declaration that extends component. Then we find the component name in the class declaration. Then we find the props type in the superclass and the body of the render class method. And then we replace this.props just with props. And then finally, we build our new function declaration with all the bits we just pulled out. So are you ready to write the complex case now? Yes. Oh, I like to hear it. I like that enthusiasm. I'm not. That was a very fast run-through of the JS CodeShift transform. I love writing code mods, but I've also spent the last decade figuring out how they work. And I had a coworker at Notion who flat out told me he just wasn't that interested. Like, these scripts get thrown out after you do your migration. You don't even really need to maintain them. What's the point? But what that means is, why don't we ask the AI to write our code mods? This is a perfect use case for the stage of AI we're in 2023. There's no internal state to a code mod. It's basically just an input and output machine, and so they're eminently unit testable. You can ask ChatGPT to write some tests, write the code mod based on the tests, and if you find some edge cases in your code base, you can augment it. So, we have our code mod, we've run it on our code base. Let's talk about the final step in the process, the long tail. Approximately the last 25% of our class components had to be converted manually. Some of these were just super high risk. Basically, if it broke, it would break the entire application. But others simply use custom functionality that were hard to look for systematically. But this first phase not only converted 550 components, but it also dramatically simplified the rest. I think at the beginning of the process, the collective group of components had over 10,000 class methods and properties. And by the time we switched to the long tail, it was less than 2,000. And so this made a huge difference. Whereas it may have previously taken months to restructure dozens of class methods and properties, it was now a matter of figuring out how to rewrite one or two and make sure it was safe. A big pain point, though, is that we were triggering these multi-thousand line PRs manually. There were often small fixes with tests and other CI checks that we weren't able to detect via the code mod. And then when this occurred, we'd sometimes run into merge conflicts. So it wasn't always the easiest to land one of these PRs. In the next migration, this was something that we were eager to improve on. So let's fast forward to this year. Again, let's figure out what the manual process of modularization looks like in the simplest case. By some definition, Notion already had a modularized code base. Our application code was organized, i.e. modularized, into client, client framework, desktop, server, and shared modules, each of which had defined use cases. And what's more, they depended on each other in an acyclic way. Great. The problem was actually inside client. This is a real picture of our client dependency graph. These dots are files. The gray lines, I know they don't look like lines because there's so many, those are import statements. The Notion application is complicated, and due to the natural addition of new features over the years, we had more than 10,000 files in our client module, many of which were very long. And unlike the module level, and because JavaScript is nonsense, there's no enforcement about how these can depend on each other. So we had thousands of import cycles. And this tangle of dependencies was starting to have an impact on our end users. Now, upon further investigation, it was clear that there was one pattern that was a big problem: the utility file. This is something that we used for developer ergonomics reasons when the company was small. But at this point, it was, again, problematic. Essentially, these were files with dozens of loosely related exported functions. As a result, they also had dozens of imports, and they became cascade points of our dependency graph. They'd usually be imported in as namespace imports as well, primarily, again, for developer ergonomics, and this posed a problem, because even if you were only using this is_sidebar_open function here, you'd end up pulling in all the imports and all the rest of the code as well. Some people in the audience may be yelling, "What about tree shaking?" Which is a fair question, and one I've had to field more than a few times. Tree shaking, for those of you who don't live and breathe bundler code, is a JavaScript-specific term for dead code elimination. Essentially, the bundler is supposed to detect which of these functions aren't used and get rid of them. But the thing is, tree shaking implementations tend to be very cautious. If there's any possibility of side effects from deleting the file, it just won't. And what's more, this isn't actually dead code. Those subscription tier helpers are used in the app, just not in this particular part of the app. So no, unfortunately, automatic tree shaking doesn't help us. So now that we've established we don't have a magic fix, what if instead of one massive file, we had many small files? Then we could just import just the function we wanted, which would guarantee only the dependencies we expect. And this was the first step in identifying and removing tangles from our dependency graph. Let's codify this algorithm. Well, first, we check that the file in question has more than one export. Then we look at the top-level functions in the file, find all the external dependencies, the internal dependencies, which are the other functions in the original file, and the source code. And using that information, we create a new function-based file with just one export and all the necessary imports. And finally, we would crawl the whole code base and update references to the utility files to point to the relevant function file instead. Now let's scale it up. So remember that a JS code shift transform is a simple one-to-one transformation. It reads the source of one file and transforms it in place. But in this case, we need to read a single utility file and produce several files as a result. Is this something we can do in JS CodeShift? Well, one of maybe the lesser known features of JS CodeShift is the reporting API. Essentially, what this does is post messages to standard out. And in this case, this transform doesn't make any changes to the original file, but writes a JSON object with the name of any variable declarations it finds. The output ends up looking like this, with each report line call beginning with the REP. And I've used this tool successfully to run the JS CodeShift transform via another script, parse this metadata, and then use that information to take some sort of action, like creating a new file. So how can we apply this to our algorithm to scale it up? Well, we'll split it up into 3 disparate steps. 1, get the information about our exported functions. 2, generate new function files. And 3, update pre-existing imports. To get the information about the functions, we use JS CodeShift, and it's very similar to the algorithm we had before. We check that the file exceeds some threshold of named exports, and then we'd iterate through all those functions, reporting external dependencies, internal dependencies, and the location of the function within the utility file. For our second step, which is generating the new file, we do this via node script, which we use that function metadata, and then we essentially concatenate all that information to generate the new file and write it to the new location. And our third step, we use JS CodeShift again, essentially searching for relevant utility file imports, and then updating them differently for named imports than for namespace imports, and deleting the original file as a result. I'm zooming through this because I'm almost out of time. Once again, I don't expect you to really go through the process of writing the code mod yourself. This is a task where the AI really excels. But it's now also 2025, so are there other tools we can leverage? Well, remember how this automated portion of the class component conversion was taking a very long time? Ideally, we want to get to the manual long tail much faster. And a lot of this was because the pain of creating these initial migration PRs and iterating on the CI checks to get them to pass. So we have our robot agent friend now who can trigger the pull requests and also fix them. This is something we ended up building ourselves, but you can also find vendors that do this. There's still a long tail, which I will skip over. There were cases where we had to fix things manually. But let's just summarize what we learned in these 2 examples. 5 years ago, we were living like primitives, writing code manually with little assistance. And we evolved. We started using AI. But the AI hallucinates, so it's hard to scale up. So we wrote some code mods to rewrite our code. What's the galaxy brain version of this progression? Well, for Rooney, I think it's learning how to open doors. But for us, in 2023, it's writing code mods with AI. And now it's writing and orchestrating code mods with AI and keep evaluating the tools. I used to be an AI hater. I don't think I'd ever trust AI to write my code. And I'm still a bit of an AI hater. But I realized that the tools are moving forward, and we should try to leverage them where they make sense. I'll leave you with this quote, because it made an impression of me. I remain an optimist about the tools, just because they're here to stay. It doesn't really make sense to do anything else. Thank you, and appreciate y'all.